All right, another kind of oddity of EOS syntax, I guess you could call it, is there's another kind of, I don't know, I wouldn't call it a macro, but a little syntax sugar that they use when they're writing their smart contracts, and it's this name kind of constructor type variable. And what this is again, this is defined in the types.hpp, if I can find it right here. So it's a very, very small struct that isn't really doing much other than, you know, taking in this value and setting it as an account name, and then it also kind of gives you this nice equals operator. As you can see up here in the description, it's a uint64 wrapper over a name variable. And kind of the same thing as previous, I created a very, very small toy smart contract example to kind of play around with this idea and kind of see what this name function actually does. Again, this is going to be kind of early on in the course, so you're not going to know a lot of what I'm doing, but just know that this is another way of compiling the smart contract and uploading it to the blockchain. That's all I'm doing here. It's very similar to the syntax I was using in the previous video where I was doing this G++ and then a.out, right? The only difference is I'm actually using the blockchain in this case. So I'm compiling and then uploading it to the blockchain and then interfacing with it in much the same way. So let's actually upload this. So right now I'm compiling the smart contract, which was the one I just showed you. And this shows that it was uploaded to the blockchain and everything went successfully. So this little bit of smart contract code is now sitting in the blockchain and we can interact with it. And this is how you do that. So what I've done is I've essentially triggered this little function here, this test function. And I'm printing out the sender of the test function. In this case, the sender was ASDF, right? And you can see that was passed as the parameter. And this little struct name here is what we were using before. Whoops, sorry about that. See here again. So this test function takes a parameter sender, and all we're doing here is we're printing it out. What you'll often see in the smart contract is this weird little syntax, and this syntax kind of throws people off. Let's see if this will actually compile. Yeah, I didn't think so. Oh wait, that's because I'm scoping it. I don't think it's going to compile either way, because I don't think the ABI will change, and so we'll throw a fit about the code version being already deployed to the blockchain, but we'll give it a shot. Yeah, I thought so. So let's just jump directly into the example. So I don't, needless to say, if I was going to upload this contract, it would still work, because I don't really need this EOS.io name constructor, because EOS.io this action already knows like EOS.io name. It already knows the sender is a name, so I don't need to scope it, I don't need to convert it, I don't need to do anything like that. I can just literally, you saw it when I ran the smart contract, when I printed out sender, everything was fine. Nothing, it didn't throw an error and it actually printed out the sender. However, this type can also be sent. This variable account name can also be sent as the parameter, and you'll see that throughout different smart contracts, depending on who's writing the smart contract, what version of Dawn you're dealing with, what style that programmer likes to use. And in this case, so actually let's just straight up print out this account name that gets sent from the smart contract, and let's hope that this compiles. Okay, it looks like it worked, and if we push the exact same code as we sent before, this is what we get. And if you remember from the previous video, I was showing you the string to name, right? It looks very similar, right? We have this uint 64, because if you look for, let's see if we can find an account name. Let's see. Oh, right here. So let's do Control B, find the account name, and account name is actually just typedef to a uint64. So that's all that was happening here in the smart contract, is a uint64 was being passed here to this test action, and so the EOSIO is printing out this uint64, right? Everything's hunky-dory as far as EOSIO is concerned. But that's not very readable to you and I, right? When I send ASDF to a smart contract, I don't expect to see 38963, blah, 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 blah. I don't want to see a uint64 when I do that. So you have this handy little macro, handy little struct, essentially, to convert that back into a readable string that you, or a readable name, sorry, that you, oh, again, with the scoping. See, most people use, previously when we were talking about intro to C++, people often do using namespace EOSIO, so they don't need to scope like I'm doing, but I actually prefer to know which functions are coming from EOSIO and which ones are coming from me or just standard C programs. So I actually prefer to use the scope over and over again. Like in this case of the account name, I don't need to scope that to EOSIO because all it is a type def uint64, right? But I know this is actually magic coming from EOSIO when I do that. So let's compile this again. Cross your fingers that it works. Okay, it looks like it worked, and if we run this again, and now we're getting ASDF. So that's all that name constructor is, right? It's this definition back over here in the types, and all we're doing is we're calling the constructor using those curly braces, and it's setting this account name for us. And now we get string conversion for free, right? The EOSIO print knows how to handle this name thing. It doesn't necessarily know how to handle the account name because it's a uint64, but it knows how to handle it and print a name. That's all the name is doing. Okay, see you in the next video.